Okay, question 5. It's a little bit different, isn't it? Because we're used to finding the area between a triangle and a sector, but we're used to it when the triangle is that triangle instead of the triangle that we've drawn here. So this is slightly different. Right, the diagram shows the sector BAC in a circle with centre A and radius 16. The angle BAC is 0.8 radians, the length AD is 7. Find the area of the region BDC. The area of the region, which region? BDC. So that sector bit there. Well, that means we need to take away from the sector the area of this triangle. That's right, isn't it? So let's work out those two things. The area of the sector, to start with, well, this is something that we've learnt. The area of a sector is r theta. No, it's not, that's the arc length. It's half r squared theta. So in the case of what we're doing here, that's a half times the radius of the sector, which is 16, squared times 0.8. What did I get for that? I got 102.4 centimetres squared. This is about remembering the formulas as well, isn't it? And making sure that we've got that learnt, we've got that memorised, but there's no excuses, we have to make sure we remember that. We're going to subtract the area of the triangle. Well, that's the triangle ABD. It's that triangle there that we're working out. Let's keep this simple. We've also got the area of a triangle is a half AB sine C. Remember? So it's a half times the two lines that are adjacent to the angle times the sine of the angle. So in this case, that's a half. The two sides adjacent to the angle are 7 and 16, and the angle is 0.8. If it's not already, we have to make sure our calculator is in radians. And then we get a value of 40.172 centimetres squared. So the area that we want, the area of BDC, is the big number, take away the little number, which is 62.2 centimetres squared to 3 significant figures. And there we go. Where did we go wrong? Well, mostly we went wrong by either forgetting to multiply by the half or forgetting to make sure our calculator is in radians to deal with the 0.8 and get a wrong value out of that. Part 2. Find the perimeter of the region BDC. Right. Well, I need to know some more things here, don't I? I need to know that length there, which is the arc length. I need to know that length, which is the third length of my triangle, of that triangle. And I need to know that length, DC, and that's the easy bit, because if this is in a circle, then 7 plus DC is 16, so DC must be 9, so we can get that bit. So let's work these out. Firstly, let's do that arc length, the arc BC. Arc length is r theta, and so r theta is just 0.8 times 16. 16 times 0.8, which is that 12.2? I think?
Yes.
Okay. We now also need the line, 12.8, sorry. Okay, we also need the line, BD. That's the line in that triangle. Ah, but look, this is perfect for the cosine rule, isn't it? Because we've got the angle and the two sides next to it, and we need the third side. So that's absolutely perfectly set up for cosine rule. Remember, cosine rule is called the cosine rule because it includes the cosine of the angle. I did again have at least one person who included sine in the cosine rule. Was that you, Matthew? No, it wasn't. Right, so that would be 16 squared plus 7 squared. They're the two sides. Plus, minus 2 times 16 times 7 times cos 0.8. And if we work that out, it gives us a value. This one is 12.2, isn't it? To three significant figures. That comes out to being 12.2. Again, in our final calculation, we're going to use the rounded value, the unrounded value, the full value for that. But therefore, the perimeter is the 12.8 plus the 12.2 plus that other side, which is 16 minus 7, or 9, and that gives us 34.0 centimetres to 3 significant figures. It's not difficult, it's just remembering the formulas, remembering arc length, area of the sector, remembering how to apply the cosine rule. All of those things are going to be there. There we go. Maths.